Welcome to Weekly Essentials number 7, Characteristics of Functions. The first function we're going to use is a linear function. We're going to begin by doing rate of change. Now, to do rate of change, you can choose 2 points that you can easily read, and you can put those points in the slope formula. Or, to do it a little bit easier, let's just use rise over run. So pick 2 points that you can easily read, this one and this one. Draw your right triangle. Your rise is 1. Your run is 1, 2, 3. Therefore, the rate of change is 1/3. For domain, with a linear function, your domain is always going to be from negative infinity to infinity. That's never going to change. And the range is going to be the same thing, except of course we're going to use our y. So whenever you're doing the characteristics of a linear function, your domain and your range will always go from negative infinity to infinity. The next thing we're going to do is determine whether this line increases or decreases. It's not going to do both. It will do one or the other. Now, if you start on the left of your line, just put your pen or pencil on the left of the line and trace it. Notice as my pen is tracing the line, notice that it is going up. Therefore, this is an increasing function, and it's increasing everywhere. If I start on the left and I follow the line, notice that line just keeps going up and up and up. So it's an increasing function, and it's increasing everywhere. And so it's increasing from negative infinity to infinity. Now, since it's increasing everywhere, it's not going to decrease at all. So we have no decreasing interval. Where does the line cross the x-axis? Well, it crosses the x-axis right here. So that's your x-intercept. That's at 6, 0. Where does your line cross the y-axis? Well, your line crosses the y-axis here at 0, -2. On the ends of your graph, what are the behaviors? Well, on the left end of the graph, notice that we are going down, because if we keep going to the left, the line's going to keep going further and further down. And on the right end of the graph, notice that if I keep going up on the right, it's going up. Let's go to the second problem. Now, in this problem, you are given 2 characteristics, and using those characteristics, the first thing I'm going to do is draw my line, and then once I draw my line, I will then fill in the characteristics chart. Well, let's begin with the y-intercept. The y-intercept is the point 0, 1. So let's plot that point on our graph. And we have a slope of -1/2. So from using the y-intercept and the slope, let's go down 1 from the y-intercept, right 2. Or from the y-intercept, you can go up 1 and left 2. And then you can draw your line. Now that I have my line drawn, let's fill in the characteristics chart. Now remember, on the previous problem, we said that domain is always going to be from negative infinity to infinity, and the range is always going to be from negative infinity to infinity. Remember, the only difference between the two is your domain has an x and your range has a y. The next thing we need to do is we need to determine whether this line is going to increase or decrease. Remember, with a linear function, it's going to do one or the other. It's not going to do both. Well, if I start on the left side of my line and I trace, I'm just going to trace here. You see how I'm going down? Therefore, this is a decreasing interval, and it's decreasing everywhere. So it's going to decrease from negative infinity to infinity. And since it's decreasing, we know it's not increasing. All right, I erased my line a little bit, so let me try to fix that so that we can continue. Now for the x-intercept, where does this graph cross the x-axis? Well, it crosses here at the point 2, 0. We were already given the y-intercept. The left end behavior, if you look on the left of your graph, notice that it is going up. The arrow's pointing up. And on the right end of your graph, it is pointing down. Let's go to problem number 3. Here we have a piecewise function. Notice this graph has 3 pieces to it. Now, since it has 3 pieces, it's going to have 3 rates of change. So if I start, I'll call this piece 1, this one is going to be piece 2, this one's piece 3. Now let's find the rate of change of each. Now, once again, you can pick points and use your slope formula, or personally, I just like to do rise over run because it's so much easier. So let's look at piece number 1. Pick 2 points that you can easily read. I'm going to pick this point and this point. All right. My rise is 1, 2, 3, 4. I'm going 4 units this way, 1 unit this way. And so the slope of that is going to be -4. So in other words, you can look at it as I'm going down 4. So that would be negative. Right 1, right is positive. So a negative over a positive is a negative. Now, let's look at piece number 2. Pick 2 points that you can easily read. I'll do this one and this one. Here's my right triangle. I'm going up 2, right 1. So up and right are both positive. So up 2, right 1. Rise over run, 2 over 1, which is 2. And then on piece number 3, let's pick these 2 points. To get from one point to the other, for example, if I do this one, I'm going up 1, left 1. So that's a slope or rate of change of -1. Our domain. Now remember, the domain would be the x's that are used in this graph. Now, notice my x's for this graph are going from here to here. So reading your graph from left to right, my domain's going from -infinity, because notice on the left there's an arrow. And then if you look at the right of your graph, notice that on the right of the graph there is no arrow. There is no arrow. There's a point. So that means the graph stops there. And at that point, my x is 1, 2, 3, 4, +4. And the x can actually equal -4. Do you see how it's a closed circle right there? Now remember, domain, you always read left to right. And that's what I just did. I started on the left of the graph. There was an arrow, so I knew it had to be infinity. And on the left, x's are negative, so negative infinity. You look on the right of the graph, there's a point, so the graph actually stops there. And at that point, my x equals 4. Now let's look at the range. Now remember, your range is your y's, and so you're going to do bottom to top. Now, on the bottom of the graph, notice that there is a point right here. There's no arrow, there's a point. And what is the y at that point? Well, it's -1, -2, -3, -4. So the y's are going to start at -4, and because it's a closed point, less than or equal to. Now, if you go to the top of your graph, notice at the top we have an arrow. Anytime you have an arrow, you know it's going to be an infinity. And when looking at y's, the top of the graph, the y's are going to positive infinity. So when you're doing your range, remember you read bottom of the graph to the top of the graph. Now, for increasing and decreasing, notice we have a mixture here. If I start on the left of my graph and I trace that graph, notice that my pen is going down. So this is decreasing. Then I'll stop at this point. If I continue to trace, I'm going to erase that part. If I continue to trace, notice now my pen is going up. So this piece is increasing. And I go up until I hit this point. I stop. Then I continue to trace, and notice now my pen is going down. That's decreasing. So I have 2 decreasing intervals and 1 increasing interval. All right, so how am I going to write those answers? Well, I have 1 increasing interval. Starting on the left, I started increasing right here. And at this point, my x is -2. And then I continue to increase until I got to this point. And at that point, my x is +1. So I increased when my x's went from -2 to 1. Now, what about the decreasing intervals? Let's start on the left of our graph. I'm going to have 2 answers because I have 2 decreasing intervals. If we start on the left, if I start tracing here, notice it's an arrow. And remember, when there's an arrow, there's an infinity. And since we're looking at x's, this is -infinity less than x. Now, trace, I'm going down, 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 down until I get here. And then I have to stop because at this point I change direction. What is the x at that point? Well, your x is -2. So there's one of my decreasing intervals. Now, what about the second one? The second time, I started decreasing right here. That's like the turning point from this interval where I was increasing, and then I changed directions. Now at that point, my x is 1 less than x less than, and then I decreased until I got here, and at that point my x is 4. Now, the next two are going to be a whole lot easier. X-intercepts and Y-intercepts. Notice that I actually have 1, 2, 3 x-intercepts. And those x-intercepts are -3, 0, 0, 0, and 3, 0. Now, what about your y-intercepts? Where does this graph cross the y-axis? Well, it actually only crosses it one time at the origin. So the y-intercept is 0, 0. What about your end behaviors? Well, if you look at the left end, notice there's an arrow, and that arrow is pointing up. So the left end behavior is up. If you look at the right end of your graph, notice it's a point. It's not going up or down. Therefore, there's no end behavior. Problem number 4. Now we're going to look at an exponential function. Is this function a growth or decay? Well, this is an exponential decay. What is the rate of change over the interval 0 to 1? This is where your x is 0. This is where your x is 1. Now, be very careful on this problem. This one's a little bit tricky. If you do your right triangle, now some students will count 1, 2, 3, but notice that going from here to here, it's not just 3 units because our graph is going by 5s. So it's 5, 10, 15. And then going this direction, we are going by 1s, and so that's 1. So going from the left, or the right to the left, excuse me, I'm going up 15 units, and I'm going left 1. And so that's going to be -15. Now, if that confused you, you could actually look at the points. You have the point 0, 25 and the point 110. And you could actually do your slope formula. 10 minus 25 over 1 minus 0, which is -15 over 1, or -15. So you could do that if that's easier for you. With exponential functions, remember, the domain is always going to be from -infinity to infinity. The range. Now, with the range, remember you always go from bottom to top. We go from bottom to top. Now, on the bottom of the graph, notice that this function is approaching the x-axis. It's approaching where y is 0. So the range is from 0, but it's not going to equal 0. Oops, sorry. It's going from 0, and then if you go to the top of your graph, there's actually an arrow there. So it's going to infinity. So my y's are going from 0 to infinity. The x-intercept. Now remember, this function is just going to approach the x-axis. It's not going to actually hit the x-axis. Therefore, there's none The y-intercept is right here, so it's the point 0.025. Now, is this function increasing or decreasing? So if you start on the left of your graph and trace, do you see how my pen is going down? And so this is a decreasing function. Left in behavior. On the left in behavior, we have an arrow, and that arrow is pointing up. And on the right end of our graph, notice that that graph is approaching 0. And then our last problem, is this a growth or a decay? Now let's think about this for a second. You know that this is what a growth looks like. So I'll put a G there. This is what a decay looks like. We don't have either one of those. Now, let's reflect both of them. In other words, if we were to turn them upside down, that would be a reflected growth. That would be a reflected decay. So if you look at those, this particular graph, problem number 5, is going to be a reflected growth. What is the rate of change from the interval 2 to 4? This is where x is 2. This is where x is 4. Drawing a triangle. Notice I'm going up 3, left 2, and of course left is negative. So negative 3/2 is our rate of change. Our exponential function has a domain of negative infinity to infinity. Now the range. For students, this is sometimes the hardest. Now remember, range goes from bottom to top. Now if you look on the bottom of your graph, notice we have an arrow. Arrow means infinity, and it's pointing down, and our y's are going down there. So that's negative infinity, less than y, less than, and notice that this graph is approaching the x-axis, and on the x-axis, my y's are 0. X-intercept, well, this function is never going to touch the x-axis. It's approaching the x-axis, so we're going to put none. Y-intercept, let's just estimate. It looks like it might be negative 0.25, somewhere around there. Is this function increasing or decreasing? So start on your left and trace. What's my pen doing? Notice that it's going down. So this is decreasing. What's happening on the ends of this graph? Well, if you look on the left end, notice that it's approaching the asymptote, which is 0, y equals 0. So on the left end, we're approaching 0. On the right end, notice my y's are going down. I hope you've enjoyed the video. I hope it's helped, and make sure you study for your weekly essential quiz. Bye.